Hello and welcome to the channel. Today I decided to record a short tutorial about Clojure Destructuring. So it's a really powerful feature, and this makes Clojure language really pleasant to work with. So the concept could be familiar to you depending on your background and which language you're coming from. So if you're coming from JavaScript or Python, probably you will see we have seen something like that and it will feel familiar. But if you're coming from plain Java, it will feel like magic for you. And I also highly recommend for beginners, if you just started learning Clojure and you got the basics, spend a bit of time and try to understand all the features of destructuring, especially for maps, because this will make your code much more readable, and you'll enjoy writing Clojure much more after you master destructuring. So without further ado, let's just dive into our editor and go through examples. So what's the deal here? So we usually we model our data in Clojure with maps, vectors, and sets, and combine them, nest them. So let's say we create a user, and it will be an object or a map with fields like name, something like age, 30, email example.com, right? So now we have access to our user, and if you want to get some properties from this map, the most basic way to do it is just to use a get function, and then the first argument will be our object, and then you put your key name here, and you're getting the value. If you're doing same, but for a key that's not there, not existing key, it will return nil, but you can always provide a default value as the last argument, like this. A shortcut for that is just to use keyword directly, so you can say name and then user. This is a valid as expression in Clojure because keywords are implementing function interface, so they are functions really. And again, this returning the same thing. You can use your non-existing key if you want. This will get nil. Not everyone knows, but as this is the function, it also can get the default value. So you can say something here and it will fall back to 1, 2, 3. So yeah, that's fine. But after that, if you want to reuse your properties, you usually will do something like username, and then do name from user, then something like user email, email from user, and then you can use your destructured values, user name. And if you always follow this pattern with naming things in a let and getting it from the map, your code tends to be longer and longer. I've seen places when experienced developers, even in tests, they just thought it's much easier to follow this pattern without thinking too much. And if you spend maybe 10 minutes refactoring that to destructuring syntax, it will collapse a lot of lines and just reduce a lot of code, unnecessary code, and you can write it in a single line or something like that. So we'll focus on map destructuring first. Usually I've seen in tutorials people starting with vectors because it's a bit simpler, but I just want to get to the most useful parts as soon as possible, so I get the idea. So we created our user, right? And let's see what we can do with that. So again, we can use the let let block. But now instead of doing this button, we can do keys, and then we can say name and email, and say user. So the thing on the right is what we're trying to destructure. The thing on the left is what we destructure it to. So keys will be same names as we have in the map. And if those names are matching, we'll get values inside these new names of the LED bindings. Let's see if that works. We can do name, email as the result of that. And you see it's working. It's not a mistake to have a non-existing key here. So it will compile and work fine. It's just like there is no key like this in the map, so you don't have the value. So this is a keyword keys to do that. In that case, it is really short syntax of describing your destructuring. But the downside of that is that you have to stick with the names of these variables or LED bindings to be exactly the same as they are named inside the map. Because in this approach, for example, is if this name was really long and ugly and you want a short name in your code, you can rename it here to something different. Obviously, you're losing this ability if you're doing destructuring with keys. But yeah, let's stick with keys. So if you want still access to some other fields, you can use as right here, and you can name this user to be something else. So you can say like current user, and then we have access to this new current user binding, and you see we have it here. So this is as. It is really a nice button. How this could be used is, for example, if you do your function and you do something like do something, and then in your arg list you want to do, so for example, let's say we have options that are passed to our function. Then we do something with these options, like I don't know, call other fn, and we provide some value from options like a from opts. But after that, you still want to pass entire options to some other function, some other fn, and some other fn still accepts ops as the argument. You can improve it by doing keys here, and you say a or whatever, like let's say my config option that you're interested in your code here. So you can do it like this, but now you basically lost the ability to pass the entire options object as you got it in your input params. But this is when as is really handy, so you just do as opts, and now this works fine. So this is a really common pattern I've seen across Clojure code bases. Okay, so this is as. Now we have or, right? And for or, what you can do is you can say or, and then you provide a map, and then you say name could be something default, like default name. And now you can say, like, for example, non existing key by default could be like 1 or whatever. And let's see what we get. So we don't care about as now, so I can remove that. So this last thing is our non-existing key, which is now 1. So that's how you can destructure. But if your input object doesn't contain a key like this, you can default to something. And it's really convenient if you write some test generate or something like that, when you most of the time want to use some defaults, but you want to add an ability to override some of the fields, so you can control it from the outside. So you always fall back to defaults, but you have option to override some fields. A really important thing here, which like a common mistake that people do, and it's really hard to catch actually. When you understand why it's like that, it makes sense, but still, like, everyone is prone to do that mistake. There is a difference between nil value and absence of the key value pair at all. So let me demonstrate. So you see here in our user, we don't have the key, non-existing key at all. So it was just name, email, and age, I believe. But what will happen if I do, instead of user, I pass a new object and I say non-existing key is nil. So now you see we have nil here as non-existing key. So this OR is not looking into the value of your destructured variable, but it actually looks if the key exists in the map. So as this key exists here, we just get the value, the structured value. So it's different from an OR macro that if you do something like nil 1, it will fall back to 1. So just make sure you understand this difference here in the destructuring. Okay, so what about usages of that? So two most common things is like do let and then keys, ABC or whatever, and then you have your some object. Right, that's the first thing. The second one is in defn, when you have your function defined, and if you're getting your arguments as the map, so we've seen that example with opts already, right? So if you want to get something from the opts straight away and bind it to some nice name, you can do it here, like my first property, etc. And then you just pass something like, it was not valid code, but you got the point. When you call your my function, you can just pass the map with first property 1, and it will be destructured here into this binding. Cool. And also it's supported in multiple places, like in let, in defn, in different macros, and all that stuff. But what about other ways to destructure maps? And there is other way. It's less commonly used from what I've seen. But instead of using key, you can just use the names and map them into something else. So let me demonstrate that. So again, let's have our let. Let's see once again what we have in our user. Again, name, email, and age. And for example, I don't want the name to be the name, right? Because it could conflict with something else. So let's say I don't want it to be called name. So I don't want to do keys name anymore, because this naming is not what I want, probably. So what I can do is I can do something like user name and name, and after that do user. And now I can call it by username and have this something, but now it's defined as username inside this let block. So this is the way of renaming things. And the other way, I'm not really recommend that, but with keys, you cannot destructure nested maps. With this thing, you can actually do it. So let's have an example. So you can do let and do something like nested map, nested map, and the object will be like A1, and then we have a nested map right here, and it will contain things like B, B2, right? So if we do nested map, we're getting this. But now you can combine that with keys destructuring right here. So the only thing you need to do is just remove this and say keys and say B, right? So now we don't have access to nested map, but we have access to B, and B is 2. So if you want to use keys straight away on the top level, you can do nested map like this. But unfortunately, the mistake that I've seen beginners doing is they try to use keys right here, like this. The problem that Clojure doesn't know which key is destructured right here, so that's why it's not working. But yeah, you can use this approach like this. My recommendation is don't go too crazy with this nested destructuring. It's much better to use an extra line here and just do nested map and just get it map from your original thing. And after that, just do destructuring either here with keys like B, something like that. Like this, or with like this named destructuring, like B. So that's my recommendation to keep your code readable. So a couple other things, really rarely used from my experience, but good to know. So without keys, obviously your map could be just name something, right? In this case, you cannot use function call like this. This will give you an error because this name first argument is not a function, so you cannot call something on a string. The way getting the value is use get and then have name here. In this case, it works, but you can use destructuring for maps like that as well. Different keyword for that, it is strings. And then you have, believe it or not, name. So it understands it from this. And then if you pass your map right here, you do name, and it should work, right? I don't know. I probably never seen that in any production code I've written in Clojure, because usually you don't have maps with strings as keys. People just tend to do some conversion to keywords on the edges of your application. So when you pass your JSON, you probably convert it to strings. When you pass your whatever files, database entries or whatever, you usually convert it to keys. So it's not commonly used, but if you end up with something like that, you can do strings. The other thing is, if you're on Clojure 11, and I'm not sure if I am, but update, yeah, there's update keys now function. It's not related to Destructuring, but just a quick one. So you can do, let me check what it gets, some map and function, yeah. So update keys, and you do keyword, and now you magically have map with keys with keywords. There's another thing for update values, but it's not useful in this case. Okay, so that was strings. The other thing is, depending on your code base again, sometimes you want to use a namespaced keywords. So it could be something like user/name 1. Let's wrap that into a map. So let's say name and something like user age 32, name, and then you can mix it with something else. So let's say A3, L3, right? That's now our new map. Oh wait, should be something like that. So in our LED block, now we can do, we still do keys, right? And that's our map that we want to destructure. And here in keys in the vector, you can just say user name, and then you will have it by name like this. As you can see, name, right? Just make it clear. Let's say Trey. So I have the correct name. So it will remove this bit of the namespace bit, and it will just map it to the name. Same as with age. So you do user age, right? And then you have age here, 32. The other way is use the user keys, which is a bit annoying, but you have age now. This is not used anymore, but this still should work, because this is a special form of that. You're basically just saying, I want keys namespaced with user, and then you map it like that. And be really careful if we add, for example, user A, and let's say 4, and then you have keys and you have A, and then you have user keys A, right? And you're getting 4. But if you do the opposite thing, you'll get 3. So make sure if you have these potentially conflicting names, be really careful with destructuring like that, because they basically will override each other. That's a bit annoying, but luckily I haven't seen too much use cases like that. Just keep your keys named consistently and use namespaces like that. Okay, so that's it. Couple other things is you can use symbol keys and use sims here. Literally never used in my life, but we can check how that works. So you have a map with symbols as keys, and then you have this LED block right here that use sims and destructure that to first name and last name, and that should print our thing. And you see it's printed correctly. And the other thing the last one about maps, is that you can use this var arc thing, and after that you can destructure it as a map. Even in the function call, it will look like this without map. And I personally don't like this syntax at all. I know some people do, and I've seen some libraries deciding to use that as their main API that goes outside. So you pass options like this. If I have to write something like that, 10 out of 10, I'll put that in an explicit map like this. That's just what I prefer. But it's good to know that you can do it like this, and also OR works and all that stuff. So let's see what we have. So this will just allow us to write it without wrapping into a map. And then we can do destructuring on this level, and this works. So the keyword debug, this value will be binded here, and verbose here, and also our OR works as expected. So let's just evaluate that and see how it works. So we see now false, false, debug true, true here, and if we run this, we have 12, true and true. So that's all about maps, and let's be really quick about vectors and collections. So we have now this thing, which is a vector, a list, and a string. And the thing that you can do is you can destructure values from that. So let's say you want the first value, like let's say vector first of all, and myVec. So now we have the entire vector here, right? 1, 2, 3, 4. If you want the first value of that, you just wrap that into another vector, and this will start your positional destructuring. So v, like the, let's say it's first value. You can put whatever name you want, like a or x or whatever. This will work. It will be the first element. So let's say like a1, a2, a3, a4. So we now have all our elements here. Basically combined it back to the same vector, but just, you see, we now have the access to individual elements from the vector by these names. And if you want to ignore something from the middle, or from like at the end, you can just don't name it. But if you want to ignore something from the middle, you can do this underscore underscore, which basically means ignore something on this place in the vector, and then you have just a1 and a4, and you have 1 and 4. And this works with vector. It will work with my list. You see, same. And also, as strings are sequences, so if you call seq on a string, you have a sequence of chars. And if you do same on your my string, it will have 1 and 1, because this is the first and this is the fourth element in the vector. It's not too commonly used, but sometimes it's used in tests. For example, if your test function returns a vector of something, you can just get first element, last element, etc. And also worth mentioning that you can still use as, like, and say like whole string here. And if you do it like this, you have the access to the entire string here as well. This is useful. So for example, if you have your test result here, you can say like as like say like events or whatever, and you can say all events here just to get access to everything. And even it's not like it's real test function, like something like get events from DB, right? That's the function that returns event. And to keep your code short, for example, you want access to all events, but also you're interested in, let's say, like first event, and second event. That's what you want to use in your test assertions. And after that, you can just say like is something is first event, then same for second event, and after that you can just do something like is, let's say 10 events is what you expect, and you do count on all events. Yeah. So in this case, your code is really short, and it's really easy to read because you use the structuring syntax for vectors. Yeah, I think that's all for today. Hope that gave you some useful information and will help you with learning destructuring in Clojure. Thanks a lot for watching again. Don't forget to like, subscribe, and write comments if you want. I also have a Buy Me a Coffee page where you can support my channel, and I highly recommend you to subscribe to my newsletter where I write blogs in a text form. And yeah, thanks a lot again. See you next video. Bye bye.